Alright, happy Monday everybody. Today we're going to finish up the Trace That Trajectory lab that we started last week. So on Friday, we went onto the PhET website, we shot the cannon, and we kind of answered these somewhat simple questions about trajectory and launching things horizontally. What you should have found out was that on part E, when you changed the mass of the object, that had no effect whatsoever on the path that cannonball followed, or the car, or the human, or whatever you launched. The mass of the object had no effect. The initial velocity and the angle definitely changed the path, but the mass had no effect on that. Okay, so skipping down to number 5, and where the second part of this lab begins, we're going to start to analyze more objects that are launched horizontally, like some of those things that you did on PhET. Okay, the first thing you'll need, it says import the movie horizontal projectile into Logger Pro. You do not have that yet, so we're going to need to go to a website. The website is this. So type that link into your web browser, goo.gl/u4zjnq. That is a Q, and it's all lowercase. I'm going to copy that because I have the privilege of doing so. Copy. I have all my stuff up still. Okay. When you paste that into your web address, it'll take you to a video that I uploaded onto Google. Now, if you play the video, it's barely more than a second. I'll replay it again. Maybe. Refresh here. Okay, however, we're going to analyze this in depth. So in order to do that, you need to download it. So this little arrow with the line below it down here is your download button. Go ahead and click that. We don't really need to open it yet, so just click Save File and hit OK. So this is now downloaded to your computer. We can use it in Logger Pro. So I told you on Friday you need to have Logger Pro downloaded. We're going to use it today. So if you go up to your search option up here for your spotlight, and we're going to click on this and type in Logger Pro, or just Logger, and it should come up. So you should have Logger Pro downloaded on your computer. Go ahead and open that up. Starting to look familiar, stuff you've used before. Now we're going to insert a movie into this. If you look at your instructions, that's what we're trying to do, is get this movie that we just downloaded onto Logger Pro. So to do that, you go up to Insert and down to Movie. Feel free to pause this at any time if I'm going too fast. Backtrack if you need to, and that's why I make the video, so you can go at your own pace. Okay, now it should be under Downloads. If you go to Downloads and you look for horizontal launch projectile, if you have an alphabetical order, I have a ton of downloads. That's what we're looking for, horizprojectile.mov. Go ahead and click Open. So that takes that video that you just downloaded from the internet and puts it straight into Logger Pro. Now we can hit play again. You see it very fast. This little bar down here, you can scroll and kind of scrub through this. If you put it towards the beginning and hit these buttons, that takes it frame by frame. So it's not that high speed of a camera. The ball's pretty blurry, but it does the job. What we're going to do is take this back to the very beginning, right before it leaves the table. So if you think about this, it's a ball. It's rolling across the table, a flat table, and then it's launched into the air. So this is a horizontally launched projectile. Alright, the next part of your lab says, advance the movie frame by frame and mark the position of the ball. Don't forget to set the origin of the coordinate system and the standard length. I know that doesn't mean much to you, so we're going to do that together. Alright, what I would like for you to do is move down here frame by frame until the ball is right at the edge of the table. So I want your screen to look exactly like mine. That ball is right on the corner of the table about to leave. Okay, what we're going to do is hit this button down here, enable the video analysis. We're going to make Logger Pro track the motion of the ball for us. When you click on this button on the bottom right, then you'll get this toolbar to the side. Now the first thing we're going to do is say that where the ball is right now, that is our 0. That's where we want the origin to be. So this third button down is Set Origin. Go ahead and click on that. Once you do, we want to bring this cursor right to the center of the ball. It doesn't have to be perfect, but just get as close as you can. There we go. Okay, so what that did was that said that position-wise, where the ball is now, that's its 0 point. If it moves to the right from here, which we know it will, that'll be the positive direction, and it's going to move down from here, that'll be the negative direction. But where it is 0. Okay, the next step is to make a mark at each frame that the ball is in the air. So starting from a time of 0, where it is right now, we're going to go to the second button and click Add Point. So try to get it as close as you can to the origin that you just put down. So right about there. That means that my ball is going to start at 0. When I click that button, the video automatically goes to the next frame in the movie. So don't click anywhere else. That's very important. Don't click at all except for the next frame. You want to click in the center of the ball now. And just keep on doing that process. Now I click in the center of the ball again. And again. And again. It does not need to be perfect, and as the ball picks up speed, it gets more and more blurry. But do your best to try to hit the center of the ball each time. Kind of helps with the pattern that's on the ball to kind of see where the center is. Like I said, it doesn't need to be perfect, but do your best. Okay, right here, the ball has just hit the ground. So this is going to be my last point that I add. Once I click the center of the ball here, you'll see it starts to bounce back up again. Do not put a dot now that the ball is bouncing back up. So this dot at the bottom where it hit the ground is your last dot. Okay, there's one more thing we need to do in this video analysis. If you look at your instructions, it says set the standard length on the video. Okay, what that means is we just showed where this ball was over an amount of time. We tracked its position. But Logger Pro has no idea about how far this ball actually moved in reference to the video. So this fourth button down says Set Scale. It has a little ruler on it. Click that button, and it doesn't actually matter which meter stick you perform this on. I'm going to do it across the bottom one. It's a little easier to see. We're going to hold down on the left side of that meter stick and drag it straight across to the other side and let go. Now it's asking you, how long was this length that we just designated? 1 meter is already the standard unit, and so that's what it should say on your computer as well. And that's how long a meter stick is, so we click OK. Alright, now we're ready to look at our data. So I'm going to click off the video and look back at my graph. And what you see in red, we have X, and in blue we have Y. We'll talk about what that means in a second. So let's go back to the lab. It says, let's start with the motion along the X-axis. Right-click the graph window and select Graph Options. In the window that shows up, select the second tab at the top, Axis Options, and unselect the Y-axis. That'll leave only the X versus T in your graph window. And sketch that to the right here. Okay, so what it's saying is to look at this graph, put 2 fingers on your trackpad, so you right-click, and you're going to Graph Options. So over here, the y-axis columns, that's what we're going to be changing on this lab. They told you to get rid of the y direction. So we're unchecking this bottom box and only looking at the position along the horizontal. Click OK. Alright, this graph is a position graph showing you how far the ball moved to the right every frame. As you can see, it's a straight line. So in the x direction, meaning the horizontal direction, as the ball moved to the right, you got this nice straight line on your position graph. That should tell you something. So what I'd like for you to do is in this graph right here, I don't need a scale on the axes, but I do want you to label them. Show me that straight line, and then in the questions that follow, talk about what that means in terms of the ball moving to the right. Okay, the next part is to predict the shape of a velocity graph if that's what our position graph looks like. So you're going to sketch that prediction here, and then we're going to check that on Logger Pro. So it says use the linear fit from your fitted line to describe the velocity. Is it in the positive or the negative direction? We're going to look at that in a second. So what you can do is click down on your graph, highlight the majority of it, and this button up here where it says linear fit, give that a click. That puts a nice best fit line through the data that you have. Over here it says M slope is 2.106 meters per second. Yours might be a little bit different, but it should be close to that, depending on where you put your markers. Okay, now we're going to switch the graph to velocity versus time. So we're going to follow part E on this lab. Okay, I'm going to exit out of that. I'm going to right click once again and go to graph options. Now over here you have everything from before. We're still looking at the x direction, except we're looking at the velocity. So I'm going to unclick my position graph and click on x velocity to see how that speed changed over time. Now the straight line on the position graph should have told you something about what you think the velocity should be. However, when you click OK, it looks like it's all over the place, which goes against what you might have thought. However, if you look at the scale, it's very, very zoomed in. So we need to adjust that scale so we can see what's happening a little bit better. So go back to graph options, and for the scaling, click on that and say auto scale from 0. That'll give you a much better picture of what's actually happening. Now we can see that that data wasn't really scattered at all. We were just so zoomed in it looked like that. It's a pretty flat line actually, which is hopefully what you guessed on your velocity graph. Great, okay, so answer the questions that go along. Draw your force diagram for the ball while it's moving along to the right. Was your answer supported by the results, and which of Newton's laws does that support? So pause the video while you work on those questions. Okay, number 7, now we're going to analyze the ball as it falls downward. So we're going to right click on the graph window, select graph options, uncheck the position in the x direction, and we're looking at the y now. Okay, so back to graph options. Get rid of the x velocity. We don't care about that anymore. We're going back to position, only we're looking in the y direction now. So we're seeing how far does this ball fall downward as it leaves the table. Okay, now with your position graph, it's starting at 0, and we're getting that nice curve downward as time goes on. Okay, that should give you a clue of what's happening in this scenario as well. You're going to sketch that graph right here. Make sure you label your axes once again. What type of motion does this ball have along the y-axis? You should be able to tell me that by now. We're going to use the curve fit to find out how the velocity changes along the y-axis. What equation should you use for the curve fit write its expression. So once again, we're highlighting the majority of these data points, and rather than linear fit, we're picking curve fit to match those points, because a straight line would not be able to go through all of them. Click on curve fit, and make sure you use this button right here. That gives you, some of you have done this in math, it gives you a quadratic function, meaning it has that squared value in it, which will give you that nice curve, quadratic. Try the fit, see what it looks like. It's looking pretty good to me. Hit OK. It'll tell you all that information up here. Part C says which general equation should you use for the curve fit, write its expression. What they're wanting is this information right here. So you can go ahead and write just each of those 3 lines if you want, but what it's saying is your A value in that equation should be about -4.8 on my screen. Your B value in that equation should be 1.763, and the C, pretty close to 0, 0.15. So kind of just write that equation down on that section of your lab. Okay, answer the questions that follow as well. What is the initial speed? Why do you think that? What is the acceleration, maybe, and why do you think that as well? Okay, then we're going to go to number 8, where we're not looking at the position anymore. We want to look at velocity versus time. So going back to this, we're going to go back to graph options, unselect position, and look at velocity instead. Click OK. So on the velocity graph, it's actually a nice straight line, relatively, right? So in terms of as the ball is going downward on the velocity graph, we see a straight line. You're going to sketch that graph once again here. What does that represent? On part C, use a linear fit to find the slope. So once again, highlight those data points. Go up to linear fit. Click on that. And it'll find that best fit line for those data points. Yours might be a little bit different than mine. But for me, the slope right here in this window, it tells me is -9.352 meters per second per second. Guys, that's pretty close to what it should be. It's pretty close to a number that we use a lot. Okay, you're going to talk about that in these following questions. So answer the rest of these questions based off those graphs. Make sure you have your sketches on there. Give the post-lab a shot. Work with your partner, work with your table, and ask me if you need any help.